Hello guys, hope you are all doing okay. And today we're going to have the next episode of the Seismic Gap series. And today it's an exciting one because we're going to talk about the San Andreas fault, which runs all the way through the state of California in the United States. I assume everyone knows where this is located, but I'm going to first talk about the tectonic setting of the San Andreas fault and other segments or splay faults that branch out of it. And then we will cover the actual seismic gaps, which I think in the news everyone talks about it in terms of news about seismology and specifically earthquakes in California. That is the big one that is coming, particularly in the southern section of the fault line, potentially affecting millions of people in the greater Los Angeles and other areas here in the southern part of the state. So, without further ado, let's begin with the geologic setting. And first, we have to understand that the San Andreas fault line is a transform boundary, just like in the previous episode we talked about the Queen Charlotte and Denali faults. And the motion accommodation is the same as before, in which the Pacific plate in the ocean is pushing upward towards this upper left in the screen, and the North American plate is rotating counterclockwise. So the motion here in the San Andreas fault line is of strike slip motion. This is one of the fastest moving strike slips on Earth. It is not quite as fast as the previous episode in which we covered the Queen Charlotte Fairweather fault, but it is quite fast, and it accommodates between 3 to 4 centimeters of the plate movement between the Pacific and the North American plate. So the fault starts right at the end of the southern end of the Cascadia fault line, which goes through the southern end of the Queen Charlotte up to here in Cape Mendocino in the northern part of the California state. And it is mainly composed of 3 main segments and also a few sub-segments, in which there is the northern segment here, which goes through the coast here into the San Francisco Bay and up to the San Juan Bautista and Hollister counties. So this part is very famous because it caused one of the most destructive earthquakes in the country of the United States. And the next section is the central segment, which is kind of a short one, and it is actually, this segment is actively creeping, which means that the motion of the plate is slipping freely, so it doesn't usually cause very big earthquakes or very long ruptures through here. And then we have the biggest section, which is the southern section here, which was also the site of a historical very big earthquake and runs through the southern parts of the valley up to the Los Angeles metro area up to San Bernardino. And there is also this complex restraining bend right here up to the Salton Sea, which is this lake here, and it's the San Bernardino segment, which continues through these mountain ranges here in the San Giorgino Mountains. And then we have many segments in here, the Mill Creek segment, the Mission Creek, and the San Gorgino Pass right here, which it releases the slip right here. Right here is, I think it was around 34 millimeters, and here the slip gets partitioned. It is divided between each fault line, a smaller fault line here. And then they all congregate in the Coachella Valley segment, or the southernmost segment of the San Andreas fault line, which goes from here up to the Salton Sea, where there is a spreading center right here at the southern part, and the fault even continues towards Mexico, but we are not going to cover those since it's not part of the main fault line. Okay, so what earthquakes happen here in the whole San Andreas fault line? Well, I think the most famous one is the 1906 San Francisco earthquake, which ruptured, I think it was more than, I think close to 400 kilometers from Cape Mendocino to the southern part here of the San Francisco Bay, and it was a very destructive event that caused more or less 3,000 fatalities and destroyed the main city of San Francisco through also a very nasty wildfire that spread through the city. And its magnitude was around 7.8, 7.9 according to numerous agencies, and depending on the total length and the slip, but it was a very big earthquake to happen in the northern section. There's also the historical earthquake of Fortejón. It happened in 1857. It ruptured the main part of the southern section, and it was a very long rupture, also of magnitude 7.9 approximately, and it had a peak slip of 6 to 7 meters, and it destroyed many parts very close to the fault line, but in the metro area of Los Angeles wasn't as populated as of today, of course. It was sparsely populated, so it didn't cause many deaths, but if it happened today, it would be like pretty disastrous and disruptive earthquake. There are so many other earthquakes that have happened in the other parts of the seismic fault line. I'm going to show you here. For example, there's the 1812 Wrightwood earthquake that ruptured also maybe another fault right here, which is the San Jacinto fault. And this earthquake ruptured through the retaining band here in the San Bernardino area. And this region is locked since these two dates in 1812 and 1857. So this part of the fault line, it has accumulated at least 5 meters or more of slip, and it's the highest it has been in the past 1,000 years in the southern section of the San Andreas fault line. Other earthquake that have happened is the 1680 Salton Sea earthquake, which happened mainly in the southern part of the Coachella Valley segment. But there is also many other ruptures, for example, the 1480 rupture, which was a very long one, which is probably one of the largest in the last 1,000 years or so, which broke many segments up to the Salton Sea. And it was probably, because we don't have records of it, it was probably around magnitude 8 or 8.1 even. And there is also the 1346 Wrightwood earthquake that was also very high magnitude, possibly 7.7 or 7.8. And there's an even previous one around the year 11,000, which ruptured almost the same as the 1480, which was also like around magnitude 8 or even higher. So in the last years, we have also seen that the last earthquake to happen here is the Fortejón earthquake. So there is a pretty big seismic gap in the southern section, mainly in the Coachella Valley segment, which runs through here. This is the Coachella Valley, which hasn't ruptured in over more than 3 centuries. And the amount of slip located here in the Fortejón rupture has also loaded up to levels seen previously in the 1857 earthquake. So what are we expecting here is a very strong seismic gap right here, which goes through all the way through Bakersfield to the south here of the Salton Sea, and this could unleash an earthquake of at least magnitude 7.8 if one or more ruptures of the fault line happen in succession. but we could also see like a very long rupture, just like we see in the 11,000 and 1480 ruptures that caused magnitude 8 or higher earthquake in the southern section. So this is a pretty big and nasty gap that we are all expecting. In the news is very talk about it. It's called the big one for California, and it is estimated to cause several thousand deaths and billions and billions of damage in the southern part of the state, with damages to infrastructure, to homes, and maybe even cause some fires that could even further destroy many parts of uninhabited places. And if you live in Southern California or even Los Angeles area, or even in California or the United States as a whole, you are probably familiar with this because it is talked a lot, and for good reason, because it is one big earthquake that is expected to strike in the very near future. We could see this happen in the next few decades. I think the possibility of seeing it in the next 10 years is very, very high. But this is not the only part of the fault line to talk about. As we said, there is the northern section, which broke in the 1906 earthquake. There was a previous rupture which happened in 1619 in San Francisco, which broke all the way down to here. The rupture was more or less the same length, but centered towards the south. This was approximately magnitude 7.7, and there was also the 1522 San Francisco earthquake, which was just a carbon copy of the 1906 earthquake, which ruptured all the way down here to the San Francisco Bay Area. So as you can see, the years between the earthquakes are more or less more than 200 years. So there are only passed 100 and so more or less years since the 1906. So the San Francisco Bay Area in theory should be like there's no seismic gap here, because there is like very recent, certainly recent rupture from Cape Mendocino to San Francisco Bay. So the main focus of the seismic gap is here to the southern part of the San Andreas fault line. But this is not all we have to talk about, because there's also another fault lines that branch out of the main fault line. Maybe some of you are familiar with the San Jacinto fault, which is right here, that crosses the San Bernardino County in the eastern part of Los Angeles metropolitan area. And this fault line it usually breaks in smaller ruptures, but it is known to cause very large ruptures every few centuries or so, and can even rupture altogether with the main San Andreas fault line. So there is also a seismic gap right here, mainly in the northern part of the fault line, and it could cause even more severe shaking for the San Bernardino basin area, which I think more than 2 million people live like around this area, like very close to the fault line. You can see there is like many homes and districts and industrial districts that are very close to the San Jacinto fault line. And there is also one right here. I think you can see here in the satellite image, which is the Elsinore fault line, which consists of the Julian segment right here in the south, the Temecula Corona segment, the Whittier, and the Chino segment right here, which is placed to the north. So this fault line hasn't happened. There hasn't been a very big earthquake in a lot of time, so it can be considered a pretty big seismic gap, which is around 180-190 kilometers long. So it can cause a magnitude 7.5 or even higher if one or more segments rupture together, and it could cause very severe shaking to the main parts of the Los Angeles metropolitan area. And last but not least, there's also right here is the Garlock fault. If you use your a bit of imagination, you can see here the crack on the Earth's crust, which is the Garlock fault. Starts at the west, in the western segment, right here, and the central segment, and also the eastern segment. It consists of these three segments, and its length is about almost 300 kilometers or so. And there is one earthquake which was recorded in a study made on the fault line, which is in the 1540 Garlock earthquake that ruptured the western and central segment. So in this fault line, the main focus here will be the easternmost segment of the Garlock fault could host a rather large earthquake, which was also the site very near here in 2019 earthquake of the right here. I think it was a fault line that ran around this path. So maybe the next one is in this area. It happens in the eastern part of the Garlock fault line. So in summary, the San Andreas fault line is one of the most prominent and major tectonic boundaries that are located in the western part of the North American continent, and it poses a significant risk to the whole Californian state, and more specifically to the southern part of California, in which there is a looming threat for more than 2 centuries that it will unleash eventually possibly a very large earthquake, or maybe even several ruptures on the San Andreas fault, and the San Jacinto, and even Elsinore or Garlock faults, which could happen in the next few years. And I think this is one of the most primed seismic gaps on the whole planet. This will be the next major rupture of the San Andreas fault line, and possibly the next major rupture to happen in the country of the United States of America. So I hope you guys enjoy this video and find it very educational. I think if you are familiar with seismology, you already knew some of or most of the information I already gave. And in the next video we will cover the fault lines located in the Caribbean, North American boundary right here in Guatemala, Mexico, and many other islands. And I will see you guys on the next episode. Hope you guys enjoyed, and I see you in the next one.